define the function AW to represent the area of the field as a function of width. Well, do you remember what area equals? Do you remember what area equals? So area is length times width, right? Length times width. So determine the function. Okay, well area is equal to length times width. Oh, we solved for length. Look at that. They were setting us up. So wherever we see an L, we're going to put actually a what? In place of the L. Because it equals it. They're equal to each other. So we're going to go ahead and take the whole equation and we're going to substitute it in for L. So then we get negative 2W plus 700. And we're going to times it with W. Way-o! And so then we could go ahead and distribute that through. And so now we get, here's our area equation. So negative 2W squared plus 700W, right? W, good. Yeah, they're going to put this one on Canvas. This is a good problem. This is really good to help you for the ACTs. Okay, so now that's it. Check. We got that one done next. Good. Okay, so then determine the maximum area. Well, this is going to be a parabola, okay? And so your maximum area is up here, right? And so your maximum area is way up there. And so that number there will be your maximum. Everything else will be below that, not as good of area. And so we want to maximize the area of our fencing. And so we just need to find the y value. The y value of the vertex. So y value of the vertex, and that will give us the maximum. That will give us the maximum equals the maximum. Maximum area. Well, how do we do that? Well, there's actually trying to find the parabola. You could graph this in your calculator. I'll also show you how to do it algebraically. And so to find this x value of the vertex, right? We can't put it in factored. Well, we could, I guess. We could put it in factored form using complete the square. But for time's sake, I know an easier formula. And so an easier formula to find the, right? To find the x value of the vertex. Because this is actually the what? That's actually, we need the vertex. And so to find that x value, easier formula. So to do our easy formula there, it's kind of like the quadratic formula. Do you remember the quadratic formula? X equals negative b plus c all over 2a. And so that's going to be our formula, and that's the x value vertex formula that you should memorize. And so that's the x value vertex formula. So we're going to come over here and we're going to label our ABCs. And so technically this is negative 2w, but it's actually a squared plus 700b. And then we don't have a c value, no c value there. So we get rid of that. But we do have our a and b. And so we go x equals negative b. What the? Sorry. It's been a while since I taught this. Let's try it again. Sorry. Okay, so what is it again? So our formula for standard form is ax squared plus bx plus c. And so we don't have a c value, there. But we do have a b value. And our b value is next to your variable, next to x. So 700 is our b value. And then negative 2 is our a value. So x equals negative b, negative 700, all over 2 is part of our formula, so I'll make it blue. So all over 2a. And what's our a again? Our a is negative 2. So that goes here. Okay, so negative divided by negative is a positive. So we get 700 divided by 2 times 2 is 4. And so what is 700? What is 700 divided by 4? It's 175. Whoa! So we found our x value of our vertex, but how do you find the y value of the vertex? Wow, this is a good problem, holy cow. So then we have our x value. How do we find the y value? How do we find the y value, which is our maximum area? Well, we take our x value, right, and we plug it back into our equation, because right now we know our x value is 175. So if we plug it back into our equation, it'll tell us what our y value is. So what's our equation again? What's our equation? It's negative 2w squared plus 700w, but we'll call it an x instead, basically. So negative 2w squared, x, technically, plus 700x. And so we're just going to go ahead and plug it in there, and we're going to go ahead and plug it in there. And so that's going to give us our y value. That's going to give our maximum area. And so that's negative 2 times 175 all squared plus 700 times 175. Woo! And so we go ahead and plug that in there. Careful. Negative, ouchie, negative 2 times 175, close parentheses, squared, plus 700 times 175. And we get a maximum area of, 61,250. Area equals 61,250. So that's one of our answers, because it is asking for the what? The maximum area. They also want you to find the length, and they also want you to find the width. Okay? And so we did find the length already, right? We found the length. Let's see here. So that's our area. And let me see. Did we find our length? Let me see. I want to make sure I do this right, so give me one more second. Sorry this video is so long. And we're back. Okay, just trying to make sure we're good there. Okay, so we're here doing stuff, and we did find our width. I just didn't show it to you. What? Yeah, so we had to take our area, which we weren't sure about, and we set it equal to 0 to get our width. And so we had to, let me see, so we found our width. Our width was so I think our width was our x value, and then our y value was the maximum area, right? Let's take a look and see. Let's see here. So we solve for w basically, right? So we go ahead and solve for w. How do you solve for w? You take your formula, negative 2w squared plus 700w. And you go ahead and pull out, we divide out, set equal to 0, right? Set equal to 0. So we pull out a negative 2w. And so when we pull out that GCF, what are we left with? We're left with w, because those cancel. We're left with the w. Those w's cancel minus. Is that 350? Yeah, so that's 350. Good. Okay, so we set each of those equal to 0. Negative 2w is equal to 0, and w minus 350 is equal to 0. And so we add 350 to the other side. And so when we add that to the other side, we get a positive 350. So there's our width. So each of those widths is going to be 350. Good. And then when we set this one equal to 0, that's interesting. When you divide by negative 2, what's 0 divided by negative 2? Well, that's just 0. So that's where we started, right? That's where we started. We started at 0. And we went all the way to 350. And so our width is going to be 350. And so then if we go ahead and plug that back in, let me see here. So we have our width is 350. And using this formula and our length, let's make sure we get our length right. And then we do know our area is 61,250. And so we can solve for L by dividing by 350. Whoa! right? Divide by 350 to the other side, solve for L, and that'll give us our length. Okay, I think it's 175 actually, but let's see. Okay, so then we got 61250, which is our maximum area, divided by the 350, and we get 175. We got it. So our area is 61,250. Our length was 175. 175. And then our width was 350. Woo, woo. Okay, good job. Thanks for watching that with me. Woo. Last one really fast is number 19. The graph of y equals x minus 6 is in standard form coordinate. Which of the following transformations, when applied to the graph y equals x, results in that graph? Okay, so we're saying that we have an absolute value of x, which is just like this. Over 1 up 1, over 1 up 1, over 1 back 1. Right? And so that's absolute value at over 1 up 1, over 2 up 2, over 3 up 3. Back 1 up 1, back 2 up 2, back 3 up 3. Right? And so what shift are we doing to do that? What's inside the absolute value? Think opposite. So it's not left 6, it's right 6. So then we go ahead and take that graph and we go 1, 2, 3, 4, 5, 6. And that's our new graph. So how do we get that new shift? We go right 6. Translation to the right 6 coordinate units. And that's going to be our answer. Boom. So thanks for watching and learning maximization with me. I know that was crazy, but it was good that we learned it together, right? And ask me more questions in class. Way-o! I'm going to put on Canvas worth points because that was a tough one. Way-o! Thanks for watching. Peace out and bye for now. See you in 2.3.